Good morning, everyone. I hope you had a nice week of sleeping in and relaxing, not having to worry about schoolwork. Um, Today's lesson, we are just going to review what we've been doing. We're going to learn a new lesson tomorrow and Wednesday. We're going to review on Thursday, and Friday we're going to end this marking period with a little test on Chapter 5. Right now I want to go over sections 5.3 and part of 5.4 that we had learned. So if you remember, we did something like this. Okay, solving equations. You want to try and get cosine of x alone. So we're going to divide both sides by 4. And you're going to get the cosine. Wait, hold on a second. I don't know if this is bleeding through. It is, so I don't want it to go on this paper. The cosine squared x equals 3 over 4. Then we square root both sides, and we're going to get the cosine x. Remember, when we square root, it's plus or minus. It's radical 3. That's not a perfect square. We'll leave it over 2. Okay, and now since it's plus and minus, that means we're going to look for the answers in all of the quadrants. Okay, because the positive cosines would be here and here, and the negative would be here and here. Okay, so what is the angle that has a cosine of the radical 3 over 2? And again, you could have your little card next to you. I prefer for you guys to remember it at this point, but I'm sure you're going to need your card to review today because you're not going to remember it. It's pi over 6. It's 5 pi over 6. It's 7 pi, excuse me, over 6. And it is 11 pi over 6. I hope you guys are all doing well. I hope everyone in your family is healthy. If you guys need to side message me about what's going on in your life, please feel free to just send me out a remind text. Okay? All right, the next one, similar type, except we're going to subtract 9 from both sides. Cotangent squared x equals 3. Okay, again, we're going to square root both sides. Remember, it's a plus or minus. It's the cotangent of x is equal to plus and minus radical 3. Cotangent doesn't help us, but we know we could flip it to give us a tangent. The tangent of x is equal to plus or minus 1 over radical 3, which of course in our world we'll never leave a radical in the denominator. We're going to rationalize it. And you're going to get plus or minus radical 3 over 3. Okay, and again, plus and minus means that you're going to find your answers in all 4 quadrants, because positive would be first and third, and negative would be second and fourth. And it works out that it's actually the same as the previous answer. It's pi over 6, it's 5 pi over 6, it's 7 pi over 6, and my favorite, 11 pi, being facetious, over 6. Okay, we also had ones like this that were a little more challenging because they had a sine and a cosine in it, and we didn't know what to do with that. But remember, this is an identity. Okay, I just want to. Okay, you should remember we have this identity sheet. You should have it. I gave it to you last time we were together. If not, again, send me a message and I will send you another one. Okay, I'll put in files someplace. All right, what we're looking at is the Pythagorean identities. Okay, so sine squared x is really 1 minus cosine squared x equals 1 minus cosine x. And now that I see I have something squared, it's going to be a quadratic. It's negative here, so I'm going to bring this to the right side. Make everything positive. So it'll be 1 equals cosine squared x. I'm going to rewrite this. Minus cosine x plus 1. I'm going to subtract 1 from both sides. And now I'm left with cosine squared x minus cosine x equals 0. Okay, this is an easy factoring. It's a GCF. I'll take out a cosine x and be left with cosine x minus 1 equals 0. Cosine of x equals 0. That's going to be a quadrantal. It's going to happen at pi over 2 and at 3 pi over 2. And cosine x minus 1 equals 0. Cosine x equals 1. X equals 0 degrees. or if you wanted to write 2 pi. Okay, so that was 5-3. That was solving equations. Let's move on to, okay, we had something like this. Find the exact value. Okay, and this is where we're going to have to use our formulas. Now, 345 is not one of the angles that's on the unicircle. It's a 315 angle. It wasn't a 345. It seems familiar because it has the 45 in it, but it wasn't. In quadrant 4, it's a 315. We can't give you the exact value of this. We could take out our calculator and look at it, but it's asking you exact value. So what you have to think of all those angles on the unicircle. How could I make 345? I can by taking the sine of 300 and adding it to 45. 300 plus 45 is 345, and this is one of my reference angles, and so is 45. Now I'm going to take my little formula sheet and look at the sum and difference formulas. Okay, I'm doing sine, the sine of A plus or minus B, and here's the formula. So I'm going to expand. Remember, this is your A, this is your B. So this is going to be the sine of 300 cosine 45 plus cosine, my way, 300 sine 45. And then I just actually put in the values. The sine of 300, since it's sine in the fourth quadrant, it's negative, radical 3 over 2. Cosine of 45 is radical 2 over 2. Plus the cosine, well, in 300 cosine is a positive, it's 1/2. Radical 2 over 2. And this is going to be, when I multiply this, this is negative radical 6 over 4, plus this is radical 2 over 4. And then I'm just going to put these together because they have the same denominator. You can leave it as negative radical 6 plus radical 2 over 4. Or if you want, a lot of people don't like leaving the negative first, so you could write as radical 2 minus radical 6 over 4. Either way is acceptable. There's no wrong answer there. They're both the same thing. Okay? Another thing we learned in that lesson was how to put them together. Okay? Cosine, cosine. I don't know the cosine of 24. It's not one of our reference angles. Neither is 36. They want to have, again, an exact value. If it's a formula like this, cosine, cosine, you know it's a cosine formula. It's going to be the cosine of 24. Since this is minus, it will be plus. That was the formula, 36. So this is the cosine of 60, and the cosine of 60 is 1/2. Okay? And the other formulas we learned were the double angle formulas. Okay? And find the values of the double angle, and I forgot to finish writing this problem. When the cosine of theta is 1/3, and you find it in quadrant 1 between 0 and 90. So first, I draw myself a little triangle in quadrant 1. Here's my theta. My cosine is 1/3, so it's adjacent over hypotenuse. I have to first find this side, so it's going to be 9 minus 1 equals that side squared, call it b, so it's 8 equals b squared, square root of 8 equals b, and of course we'll write that in the correct form, which is 2 radical 2. All right, now I know what my cosine is, so technically I could tell you what my sine is. My sine is going to be 2 radical 2 over 3. Okay, the sine of theta. Now I could do my double angle formulas. Okay, and again, the double angle formulas are also on your sheet. Okay, they're right here, double angle formulas. So, to find the sine of the double angle is 2 times the sine times the cosine. So it's 2 times 2 radical 2 over 3 times 1/3, and that simply is going to be 4 radical 2 over 9. And that's your answer. That's simple. The cosine of the double angle, okay, cosine, if you remember, there was a whole bunch of them. There was 3. One you could use both, one you could just use cosine, and one you could just use sine. I'm just going to do the one that is cosine. Actually, yeah, I'm just going to do the cosine one. So it's going to be, you do whatever one you want to do. 2 times the cosine squared minus 1. 2 times, cosine is 1/3. I'm going to square it in my head and get 1/9 minus 1. This is going to be 2/9 minus, I'm going to change that 1 to 9/9 so I can subtract it, and my answer is negative 7/9. And now remember tangent of 2 theta, all right? There is a formula. It's kind of a messy formula, but I know that tangent is always sine over cosine. So tangent of a double angle is the sine of the double angle over the cosine. So it's just this over this. Since they both have the same denominators, that's going to cancel out when I divide it. So it's just going to be 4 radical 2 over 7. And of course, it's a negative when you put that over that. Okay, guys. I hope that sparked some memory in your head. I'm going to attach a sheet for you guys to do just to review what we've did. And actually, it's a good review for the test that we're going to be having on Friday. The test that I'm going to send out on Friday is going to follow the same format of, excuse me, the same format of what we did with that quiz. All right, I hope everybody's safe. Love you guys, miss you guys. And again, if anything's going on and you want to talk, I'm here, so just send me out a text.